Okay, so now we are recording. Welcome to everyone to the October meetup for VdoTech. We are very happy to welcome Aditya from Yuktamedia and Siddhant from VdoCipher. Aditya is going to be talking about basically data capture. How do you gather data? How do you clean data? How do you present it so that you can actually run a good system at the end of the day. And Siddhant with VdoCipher works primarily on DRM. So he's going to be talking to us about DRM, multi-DRM, and problems faced in an Indian video setup. So just a quick introduction to InVideoTech. So we have been around for 3 or 4 months now. We try and organize a meetup every month, typically the last Saturday of the month. And we try to invite people, experts from the industry to talk about something technical which will appeal to people interested in video, essentially. We also have a Slack group where we'll send out an invite after this session where you're free to join. There are a lot of groups where you can discuss with others, meet like-minded people in the industry. So like I mentioned a few minutes before, if you know of somebody or if you would like to present something quite technical and you think it'll be interesting for the community at large, please message any of us. We'll get in touch with you and we'll put you into one of the slots for the meetup. Okay. So without further ado, let me hand it over to Siddhant.
Thanks, Krishna. So it is good to see a community around video tech coming up, and like happy to be part of it. Thanks for the introduction. I will share my screen and start the talk. So is it visible?
Yeah, perfect.
Okay, sure. So firstly, like we will talk about video DRM, what like security means when we say that it is a DRM protected like video which is playing. What are the security parameters? Then like as a developer, what are the things you have to take care of while integrating a DRM? Then compatibility. So is DRM supported across all browsers, all devices, or there are certain limitations? And what are those limitations in a brief? And if there are any issues particularly which come especially with the DRM, and also some Indian context to it, that certain issues which are like which might not happen that much in USA but might happen more in India. So that is the gist of like the talk which we are going to have. And so like firstly, like I am like myself don't code, so I'm not a developer, but I am a product and a business guy, and I also regularly talk to clients, so I have an overall idea of everything and I understand technology decently. But this wouldn't be a very technical talk because I am not a developer myself.
Sorry, Siddhant, can you tell us a little bit about what you guys do at VdoCipher?
Yeah.
What is your connection with this? Yeah.
Right. So, so at VdoCipher, we provide video hosting solutions, and where we have integrated DRM inside. Okay, so we provide like video hosting solutions with highest security. So, just like in a brief, I have to tell whatever Netflix is doing in-house, we provide it as a solution so that any media platform or any education platform can use it. So we are bringing Netflix-like security within the reach of all kind of businesses. So that is in short what we do.
Okay, and so then this is something you sell typically to the OTT players or other media players who want to show videos?
Right. So it is typically sold to OTT and like education players who are selling their videos at a price.
Okay, got it. Thank you.
Okay. And like the presentation would be more from not from like a VdoCipher perspective. It would be more from just a like a DRM. What is DRM? Why it is in place and those things. So it applies even if you are if you don't have any correlation with VdoCipher. Like it is just a general talk.
Perfect. So we have 20 minutes for the presentation and 10 minutes for Q&A. So let's go for it.
Yeah. Okay. Sure.
Thanks, Siddhant.
So firstly, why specifically video DRM when encryption is already there? Okay, so you might have heard of technologies like HLS encryption, AES encryption, AES-128, RTMP encryption, which are already there in the like market, which are open source technologies. And as a developer, somebody can implement these technologies and encrypt the content. like if you don't want to even yourself encrypt, then there are again providers, technology providers, who will do this encryption and video playback part for you. So when there are technologies on encryption available, so how is video DRM different from these? So video DRM typically stands for video DRM is digital rights management. But the when we say video DRM, it specifically means certain things. So for example, today when we say tech startups, uh, ideally from English perspective, it could have meant a chemical engineering or biotech startup, but no, we have just synonymized tech with a software tech. So that is why, like when we say tech startup, it is like we are saying only talking about software tech. So similarly, when we say video DRM, it is essentially about protocols which are essentially maintained by companies like Google, Apple, and Microsoft to high secure the videos. So there is a specific segment which we are talking about. Now the technologies which are already open source available, like HLS, AES, and RTMP encryption, uh, so they provide encryption. So they are better than YouTube or Vimeo in terms that YouTube is not encrypted at all, while these technologies are encrypted. But what happens is that ultimately when the video is playing inside the player, the content has to play in a normal way. So there is a key which is there to decrypt the content. So the same key which is used to encrypt the content, it has again to decrypt the content inside the player so that it is it can open in a browser or in an app. Now, since this key exchange is there, it is somewhere in the network. So in the technologies like HLS, AES, and RTMP encryption, that key exchange mechanism is not like very hardcore secure. It is somewhere in the like network or the player that somebody can sniff into the key. So that is why there are already existing tools and hacks built which can grab this key. And since you get the key, and even if you have a content encrypted, you can put together the encrypted content and key together to get the raw video. So essentially, because of this weak key, like you can not, I will not say weak, but yeah, little bit open key exchange mechanism that most of the standard encryption technologies, they have been broken, and like people have already built tools to download it. So that is why DRM comes into place, where the key exchange mechanism can be made more secure. Now, why DRM can make a key exchange mechanism more secure? So fundamentally, Google, Apple, or Microsoft, they have a like a browser OS or hardware level control. As an example, I am currently playing this in say Chrome. So Chrome has as a browser level control over whatever the video is playing in a browser. If I am watching in an Android phone of say Samsung, then Android has like Google has an OS level control via Android. If I am watching it in a Mac Safari or in an iPhone, then Apple even has a hardware level control. So since these providers have like a larger control over the playback either via browser or via OS or via hardware, they can ensure that this key exchange mechanism, which is very open in case of standard technologies, it is not the case with them. So they have essentially built something called EMEs and CDMs, which is encrypted media extensions and CDMs, and they have put it in like devices and browsers so that the key exchange mechanism can be made very secure. So that is the essential need of video DRM, even though there are encryption technologies already available. So now, as a like a platform owner or as like if I have to build a video hosting solution and I want to get the highest security via DRM, what will I do? Okay. So firstly, I can try to get this Widevine. So there are three particularly DRMs which we'll talk about. One is Google Widevine, second is Apple Fairplay, and the third is Microsoft Play Ready. So I may try to reach Google, Apple, and Microsoft individually myself, and try to get a partnership with them and implement these like these DRMs and do a complete infrastructure. But that would be a very tedious task. So somebody like Netflix or Amazon Prime or Hotstar, they typically have their individual contracts with Google, Microsoft, and Apple, and they do it totally themselves in house. But even a large player like I will say Z5 or Sony, Live, etc., they don't do these DRMs themselves. They typically look for a provider who can provide, who have already made an infrastructure around this, who already have the licenses from the respective like authorities, and they can provide them the DRM integrations. So because primarily of time, energy, and technical constraints, most of the platforms small, medium, all of those, and even many large platforms, they look for a external company to provide them this DRM security offering as a and as an as a SaaS solution. So these DRM companies can be like VdoCipher, and there are many of our competitors which are out there. So specifically, I haven't seen many like any India specific DRM company, but outside India in USA there are many companies like this. So what a DRM company typically does is, so we, for example, have a direct license with a partnership with like Google Widevine. And there are certain requirements if you have to get a license from Google Widevine. For example, two of your employees have to be always trained with the license. You have to attend a training. Then there is infrastructure which you have to set up in accordance with Google. So essentially, whenever somebody is playing a video from like a DRM partner license, even the Google or Microsoft or Apple also knows it, that this video is playing through this partner, not this video, but yes, this like this view is happening from this partner and this license. So it is in always in the connection with the primary companies like Google and Apple. Um, so, so this was the context of like why there are DRM companies in place. So the Google's and Microsoft license is like bit simple in the sense that like we as an integrator, VdoCipher as an integrator, we don't have to build a different license for each client. I mean, like we have a single license from Google, and we can distribute it to many people without having to talk to Google again and again. But this is not the case with an Apple. So Apple has a requirement that the content distributor or the content owner. So if like suppose I talk to an OTT platform, so the OTT platform has to apply for the license, while a DRM integrator like VdoCipher can do everything technical. But the license, official license, is only given to the content distributor or the owner. It is not given to an integrator like us. So this was around getting a DRM license. Then the next is so when you are trying to integrate, okay, so you talk to some like DRM partner company, or you have got the DRM license yourself, then how will you integrate it? So there are two primary points of integration. One thing is on the encryption side, which is after encoding. So suppose you have a video and you have made it into three different qualities, you have done those transcoding parts, then after transcoding, you will do the encryption. Uh, Similarly, then in the player, you have to decrypt the videos. In the player also, you will integrate certain decryption APIs. So after transcoding, there are certain encryption APIs which you have to use, and then inside the player, there are certain decryption APIs which you have to use. So these are provided by most DRM providers like us, and so they can vary from platform to platform. But one thing which is interesting here is that these encryption and decryption APIs, they work with certain mentioned technologies on the player and the streaming protocol side. So for example, HLS can play on everywhere. So HLS can play on a desktop, on an Android and on an iOS. But if you have to implement Google Widevine DRM on a desktop, you cannot do it with HLS. Okay, you have to do it with Dash protocol. So these DRMs come with their own set of like guidelines on that you have to maintain these protocols. So essentially, if you are doing DRM, you have to maintain at least two protocols to be able to have all platform compatibility. If you weren't doing DRM, you might have done with just one streaming protocol. Similarly, on the player side, you might have, or everybody might have heard of open source player like Exo Player, VdoJS. So they essentially have parameters available for DRM integration. So you have to like plug in those parameters to be able to integrate DRM on the player side. But if somebody says building their own proprietary player, they are not using these standard players, then they wouldn't be able to integrate DRMs, because DRMs have maintained certain parameters which are only available for integration in certain open source players. So this is mainly around integration on the encryption side, on the decryption side. So for example, this is some sample document where you see that there are parameters provided like signing key, signing IV. So this is typically provided by the DRM provider, and somebody has to integrate this on their say encoding side to be able to encrypt the content. Um, Similarly, on the player side, then there is again certain code to be integrated for the content to be finally able to play in an normal way. Then in terms of compatibility, so there is a certain compatibility metrics. So for example, Google's wideband DRM, it works in desktop, Chrome, Firefox, Edge, Android systems like app, browser, Chromecast, etc. Apple Fairplay is primarily for our Apple related devices like iOS, Mac, Safari, iOS app. Then Microsoft Play Ready is for Windows Edge. One thing interesting here is that both Google's Widevine and Microsoft Play Ready, they can work in Edge. So it was not the case before, around 3-4 months before, it was not the case. But since like now Edge is also Chromium based, so from Edge 79 onwards, they also have built-in support for like Google Widevine DRM. But the security which comes with Google Widevine and Microsoft Play Ready, it is a little bit different. But primarily, like both DRM support Edge. um, then like WebView apps are not supported. So if a platform is building an app, so if they are building say a native app, then it is good. But if somebody is building say WebView apps, then the support is very poor. So the iOS DRM support is totally not there for a WebView app. And for something like Android, like in Android, the WebView support is not full. So it might play in certain devices, it might not play in certain devices. So it is like, that is why if you are trying to have an DRM integrated, it is good to go with a native app. Um, so then coming to security levels, what are the securities which are essentially provided between these DRMs? So these DRMs actually ensure that the content cannot be downloaded. So wherever they play, that they ensure that the content can't be downloaded. It is almost impossible to download. I wouldn't say impossible because nothing in security is impossible, but it is almost impossible to download content if it is played via these DRMs. But screen capture prevention is not everybody. It is not everywhere. So, for example, if you watch a Netflix video, if you try to screen capture it from your Chrome in desktop, you will be able to screen capture it. But if you try to screen capture it from a Safari, or say an Edge, then you wouldn't be able to screen capture it most cases. So there is a difference between screen capture level of protection in the DRMs for different browsers and different devices. In terms of download prevention, they all do pretty much good, even though there are levels inside it. But in terms of download prevention, they all do pretty much good. But in terms of screen capture prevention, there are different levels across browsers and across devices. So sometimes it is typically just marked as something sold as Google Widevine L1 and Google Widevine L3. So if you're buying a phone, then say if you're buying a Redmi phone, and if you buy a very costly phone, then it would be most probably an L1 compatible device. But if you're buying a low-end phone, say 6,000-7,000 rupees phone, then it would be in most probable case an L3 compatible device. So what it means is that L1 is a higher security measure. So the like in the most cases, the high end devices, they have a higher security compatibility available, while on the low end devices they are low security compatible. So how it affects is that certain OTT platforms, particularly Hollywood media, I haven't seen much that happening in Indian media, but Hollywood media, they decide to stream the Ultra HD or Full HD only in say the higher security compatibility devices, say Widevine L1, while they decide not to play the HD content, the full HD content in L3 devices. So you can also try this. Like if you can check a video, a Hollywood recent movie in Netflix on your Chrome and on your Edge and Safari. So the quality on Chrome might be a bit less, so it might be 720p, while the quality in the Safari or Edge might be 1080p. So this is mainly from the content provider. It is not essentially built inside the technology, but just to ensure highest security for their highest HD content or say 4K content. These most of the Hollywood platforms, they stick to these requirements that you only play the highest quality at a certain security level. Beyond that, you maximum do 720p or say 600p. So like L1 and L3 are just like overall parameters, but within these also there are HDCP parameters. So HDCP are essentially like systems which are built into uh, block like video output. So they control video output. So within even these DRMs, even if you say a widevine L1, within this even itself, there might be certain other parameters to ensure higher or like lower security. Um, yeah. You will see a lot of news now these are days around wideband L1 and L3. So this is a news article which says how to restore wideband L1 DRM and Oppo. This is a news article which says OnePlus 8 Pro DRM wideband L3 issue confirmed by OnePlus. So if you just see the news section of the Google and you search for wideband, there will be many news related to phones which are there. So why are these news available? So one thing is, as I mentioned, that certain devices which are L3, they wouldn't be able to play HD of providers like Netflix or any primarily Hollywood grade provider. So like as a user who is expecting to be able to watch in 1080p, if they have a phone which is say wideband L3, then they wouldn't be able to watch it in full HD. To me personally, on a phone 720p or 1080p wouldn't I don't feel it much different, but for certain like say users it might be a different. So that is why when people nowadays it has come in news that when people look out to buy for a phone, they also try to ensure that it is also highest security compatible so that they can ensure the highest quality from a Netflix or Amazon Prime. So this has become a small criteria even in a purchase decision from a like a phone perspective. um, so this is mainly about like what is DRM, how it is integrated, how it is works, what are the security levels. Now I will come into more into the issue side of it. That if there are certain issues with DRMs and what are those. So firstly, without even an issue, there is a compatibility limit. So if I look at this compatibility matrix, I have only mentioned Android Chrome and Android Edge. I haven't mentioned other browsers like Firefox or say like for example the UC browser was popular already there. So there are certain browser limitations. I haven't mentioned Opera here. Okay. So these DRMs can only play in certain browsers where they are compatible with. So it is not 100% all browser compatibility, but yes, they support major browsers, so it is fine. Okay. So this is not an issue, but this is a compatibility limit. So that is why somebody like YouTube, which is from Google itself, they don't implement DRM because they don't want to even lose on any of the browsers. They want it to be playing everywhere. Okay. Then what are the issues which can come? Okay. What happens is so the issues don't come primarily in desktop or in an Apple like Apple system like in an iPhone. So why they don't come is because the OS is and the OS and different browsers control much of them. In Apple, like Apple controls everything, so it is fine. Like in a laptop also, whether it is a Windows or a Mac laptop, like Windows OS and Mac OS, they do things quite decently. But the issue comes when somebody like Redmi or UI comes in. Now Google has an Android system, but as you have seen that these like Redmi phones, they modify it and they put in there some of their own things and they sell it as a like a final phone. So since people like companies like Redmi or Huawei, they implement their own OS along with Android OS. In certain cases, though the phone should be have been fully DRM compatible, it is not. So when I'm saying it is not DRM compatible, it means that that phone might not even play any DRM protected video at all. So one common case which we have seen in from our experiences, Redmi Note 8 Pro. So it is like most of the Redmi Note 8 Pros would be able to play content. So around 80% will be able to play a DRM protected content, but 20% around wouldn't be able to play a DRM protected content. Uh, this is because Redmi had would have made certain mistakes while they had launched this phone in the OS, which gave this issue. In certain cases, we see that like an OS update solves this. Redmi also because works on these things, and in certain cases, factory reset solves it. But factory reset cannot be done by like every viewer because it will erase a lot of their data. But an OS reset or a factory reset can solve these DRM issues, but it is not necessary that it will solve. So this is primarily for Android phones, which there is error. That is why I had said it that it is more in the Indian context, because when we talk of say USA market, there wouldn't be much Redmi Android phones available throughout the USA market. So there wouldn't be many issues. But when you're in Indian market, then there are a lot of Redmi phones which are available, and there would be this issue. So this issue is not like single to Redmi. It can happen on other devices like certain Huawei devices or certain Samsung devices, but it is very less there. So in the most cases, it is primarily in Redmi devices. So when a DRM provider provides an integration, they also provide you error code, so that this error code should display when this error is coming, so that you and the viewer also knows that why this error is coming. So for example, when I say Redmi Note 8 Pro, so we as a DRM provider, we try to give a certain message so that like our customers can take an action basis of like that message. UI also has certain problems. So we didn't see many UI devices in India, so we hadn't faced any issues before. But now we have seen in Middle East and in Sri Lanka, there is certain level of a certain percentage of UI devices also which face issues on the DRM level. So overall, this DRM issues would be in I guess 0.5% of the devices. But if you have overall like million users, then that 0.5% would be still a very significant number. In certain cases, Google also knows of these issues. Okay, that the Redmi or UI, they are like facing issues, and sometimes Google also tries to correct it from their selves. But in many cases, it is more of an issue from the device provider itself. So they have to also update. So it is a constant work by the manufacturing and the OS companies and the likes of Google to update compatibility so that it becomes better and better over the time. Um, so for example, we have like for a particular error code, we have this whole set of instructions mentioning that what is the reason for a particular DRM error, and then how it can be corrected. Then for these kind of DRM errors, like what is the reason for these and how it can be corrected. Uh, these are the guidelines which essentially a DRM provider typically provides to help in these compatibility issues. So one thing extra, which is that even in Android browsers, so even though DRM is supported in Chrome, but it is not 100% supported. 1% or 0.5% of the Android Chrome browsers also wouldn't play DRM. So if you build an app in an suppose there is a phone which is not playing a wideband DRM video in an Android Chrome, but if you try it playing in an Android app, it will play. So it is essentially a browser level error, not a like phone level error. So that is why one reason why many providers like Netflix, etc., they are not a mobile browser openable, they only force you to app, is security. So one major reason is of course the experience and control over which you can have in an app, but one reason is also security compatibility, because the Android browser compatibility of a wideband DRM, it is 99%, it is not 100%. So the final bit of it, what a developer or a platform owner or like a DRM provider can do in case of these 0.5 or 1% of DRM issues. Like first thing is, as I mentioned, they can try resetting the device or OS so that it might correct it. Secondly, if it doesn't even correct by say updating OS, or say in a worst case say a factory reset, then you can't pretty much do anything. So that device then wouldn't play the DRM protected content. Because it doesn't have the necessary compatibility, so it wouldn't play the DRM protected content. So now as a platform, it is your choice whether you want to give an alternate technology in case of where the DRM is failing. So for example, as in VdoCipher, some of our customers try to, like, we actually provide them an alternate encryption in case where DRM is failing. But certain providers which are hard bent on security, which want highest security, they don't want to leave any loopholes. So they go for solutions where it is only DRM security, and if it doesn't play in 0.5% of devices, mobile devices, then it is fine for them. In certain cases, if the experience matters more than security, then people can try to give a low security version and another encrypted version with a lower video quality, not the highest quality, to ensure that the viewer experience is also there, in like by compromising a bit of security. So this is like a typical approach for a like a non for a playback which for a device which doesn't support DRM, either to block it or either to provide an alternate way to play the content. So that was all from my side. So thank you. If there are any particular questions on any part, you can ask.
Thanks, Siddhant. I think there are quite a few questions on the chat.
Okay.
So first was a couple of questions from Aditya. So what is the need for why is encryption necessary, and is decryption done on the client or the server?
Yeah. So firstly, why is encryption necessary? So YouTube isn't encrypted, and there are 100 downloaders which can decrypt a YouTube video. Vimeo isn't encrypted, and there are again 100 downloaders which can decrypt a Vimeo video. So if you are selling a content at a price, you wouldn't want people to be downloading it and sharing it anywhere else. So it is a revenue loss for the content creator. That is why encryption is needed. But as also mentioned, even a simple encryption doesn't work. So for example, these open standard encryption technologies, they don't work because there are already tools built in to break them. So for HLS, there is something called HLS fetch. For RTMP, there is something called RTMP dump, which is already there to like get a raw video from these technologies. So that is why the need of DRM. If you want your content not to be able to download it, then you need a DRM essentially. What was the second part, Krishna?
Is decryption done on the client or the server side?
Okay. Yeah. So the decryption is done on the player only. Okay. So the encryption happens on the like encoding side where you built your encoder. So there is the encryption, and the decryption is done on the final player. So in a like if so just open. So in a simple HTML5 player in a browser case, it is decryption happens inside it. But since this player has already built-in parameters integrated for like a decryption, so it can decrypt a DRM video. So it is a simple HTML5 player for a browser. In case of other things like Android app, it is an XO player which can do the decryption.
Okay. Aditya, did you have any follow-ups?
No, I think that is definitely useful. Does decryption induce any latency when the video is playing? Number one. Number two is it one-time decryption that once the video, before the video starts playing, it's decrypted and then that's it, then it continues to play?
So firstly, it doesn't put a lag. So we have seen that so like by the standards how it is built, it is very because it has been now maintained by people like Google, Microsoft, and Apple. So they have worked to ensure that on the player side there isn't much like extra. But what from we have seen is that on desktop and Apple again there is no issue. On an Android system, it like everywhere it plays fine in terms of like lag. But if you do try to do a speed change of say 1.5x or 2x, then there is sometimes there is a high like RAM usage which can occur and which can cause certain issues. But it only occurs for 1.5 or higher speeds in like a small number of Android devices. As such, there is no issue for overall like overall thing. And uh, yeah, what was the second question?
Is it does decryption happen at the beginning, or is it on ongoing as you get the video snippets from the server, they get decrypted, or just when it starts?
Okay, yeah, Aditya. So if you know that most of these streaming protocols like Dash or like HLS or whatever they are, so they essentially give videos in chunks.
Yeah.
Okay, so since video comes in chunks, so the encryption like it is coming in encrypted in chunk, and that is why even the decryption will happen in chunks. So it happens all across the playback, and also these DRMs actually apply to live streaming as well. Then there is in fact like there is no choice. It has to open. The decryption has to go on the fly. So the decryption happens on the fly.
Okay, and if the video is buffered, right? So if the video is buffered, does that have any impact on the decryption process?
No, so it is like in terms of players, so it is a standard player. So you have all watched Amazon Prime, Netflix, etc. You see that that player is no way less than a YouTube player. It plays as fine and as similar technologies. So there is no like as such lag or anything different in terms of DRM. Just before it was playing direct MP4 thing or like direct whatever video URL, video playback. Now it is just decrypting it finally in the player as it is playing.
Okay. Okay.
So yes, the buffered content, the future buffered content is already decrypted. So if it is like future buffered, then it means that it is already decrypted and it is present there in the network itself.
Right. Okay. That's
okay. Fantastic. So we have a question from Karthikeyan. COVID-19 has provided a good number of business opportunities for video conferencing, virtual live streaming startups. Example, Hublio. How can we build secure live streaming systems using open source technologies?
Okay. So yes, I've heard about Hublio. So firstly, so when I talk about like more security, this DRM, so this essentially also comes with a live. So for example, we have an education provider who does live classes, and they are using it for their live as well. And there were certain other cases where the CCTV stream was to be encrypted for certain privacy reasons. So even there it like was. So the live, as such, the one-to-many live is where the DRM works well, and it is already used all across the world. But the case which they are mentioning is around a video conferencing, which means it is one-on-one, and it is a two-way interaction. So typically, currently, so this DRM can work in there, but there haven't been much integrations on the DRM side. So, for example, when Zoom does a video conferencing, firstly, since Zoom is a software, it is not a browser-based thing. So, like they have their own technology to like encrypt and secure content. They don't use DRM. So for a video conferencing solution, it can be used, but it hasn't been done like much before. Okay. In terms of COVID and building like a secure system, so I think in a video conferencing solution, the first requirement is of the it's of the lag and the experience. So that is why now we are talking this on Zoom, not on Google or Skype, because over the time we have seen that Zoom does work typically somehow at least somewhat better. So that is the first thing, which is more which one has to work more if they have to work on a platform. And secondly, as from a business perspective, now if you have heard of news that Zoom has open their APIs to be able to for people to build solutions over it. So I don't know much details about it, but if somebody wants to start from directly a point where Zoom has already done a work, then you can try to integrate Zoom APIs for your own platform so that Zoom is already built into your system.
Okay, Karthikeyan, anything else on that?
Yeah. So I have one more question. Yes, Siddhant, thank you for the answer. So you were mentioning about the Redmi, right? Because Redmi plus the 80% of the contents, like with the DRM compatibly, the remaining 20 it has a error issue, like any DRM issues, right? So how about because when I was working in AT&T, right? So we were using a Cisco video card evidence, the multi DRM framework. How about can we use the multi DRM framework here also with the Redmi, right?
Firstly, like just to clear, 20% of Redmi doesn't face issue. 20% of Redmi Note 8 Pro face issue. So like most of the Redmi wouldn't face an issue. Redmi Note 8 Pro has a tendency to face the issue more. Out of that Redmi Note 8 Pro, I have seen that around 20% the face the issue. So uh, like other DRMs wouldn't support it. So in an Android system, only a Google Wideband DRM is supported. So you can't have a third DRM and to play instead of Google Wideband. So that is not possible in an Android system. But you can have another encryption technology, for example, HLS encryption, to play instead of DRM in case a device it is failing. But then it is a slight of like a weak security, because essentially a system is as secure as the weakest point. So if you are providing like an alternate encrypted technology, then it will work in cases of Redmi Note 8 Pro. But then it can be also used by some hacker to exploit the exploit and get the video.
Thank you. Yeah, got my point. Got the point. Yeah.
Okay, we have a question from Sanjeev from the content side. How would someone set the levels L1 versus L3?
Okay, so this is so these levels are to be set in the like by the so DRM partner provides APIs. So a company like VdoCipher provides APIs for all setting all these parameters, and it is on the platform developer, so whoever is developing the platform, to like set these parameters. So within the DRM there are a lot of parameters, and the platform owner can decide that which parameter to play, which quality, or which parameter to not play not play the video at all. So that can be decided by the platform developers themselves. And in terms of content, so like if you are building your own content, if say if somebody in India is having their own content on their own platform, So they can play it on everywhere. I think wide on L1, L3, like most I haven't seen that Hotstar quality degrades with L3. So they like play HD everywhere. But typically, like only like Hollywood people, they have that. They want to only play highest HD at the L1, while like 720p in L3. So that is on the content owner to make that decision, and then it is on the platform owner to have that integration.
Okay. Sanjeev?
Can you hear me?
Yeah.
Yeah, I got that. Thanks.
Okay, cool. So I had a question. You said that L1, L3, I mean, a provider can decide to block UHD or 4K resolutions on L3 devices, L3 compatible devices. So now where does this decisioning actually take place? Is it when the person presses play that a particular license is returned from the license server, or is a flat license returned and something happens at the CDM level which blocks 4K?
Okay. No, so it is at the licensing level. So like at the start of like each playback, when a person clicks on play, actually before even play, there is a certain thing loaded. So most of the video players even preload certain content. At that point, like a device detection is done, and like DRM, like the integrated. So the point where you have integrated the DRM, that knows by that time before a playback even, like when a click is done, that whether it is an L1 or L3, and then so that is why sorry so you mean the quality difference? If somebody is providing a quality difference, then how it is decided, right?
Yeah. So where does the decision take place? So I just press play. Mine is an L3 phone. So is the decision taken to not provide 4K at the server level, or does it happen at the device? Like something is blocked at the device and the player cannot ask for 4K?
Okay. So it is like the decision is made at the server level when you are building the video URLs. So you specify that the video URLs uh, are like this quality should only go to this and this quality is. So essentially the decision is made at when the video player is loaded. So when the video player is loading, suppose you load a page or you load an app. So even before you click a play button, by that time like it is known to the video player that you are L1 and L3, and that is why then it makes a decision.
Okay. Okay.
And there is a tool called so it is called DRM Info. So there is a tool called DRM Info, which is like a popular Play Store app, like which people can see that what exactly the DRM specifications of a device are. Like in terms of if you are interested to see in what happens in your phone.
Cool. That's interesting. Okay, thanks. So next question, I think we have a couple of more questions and then we can move on to the next session. So we have a question from Alok, who has been able to join us. So Alok says, how do you see the future of video DRM in terms of CMAF and CENC?
Okay. So like as I was initially said, so I'm not a bit of like developer. I don't develop technologies myself. So I understand CNC, but I don't have any idea of CMF, so I can't like comment on it.
Okay. I was just looking at this on the side, Alok. What I see is that if people use CBCS encryption, they might be able to use CMAF for both HLS and Dash, but they have to use CBCS, I think.
So we have worked on CBCS. So whenever like these new things come, and essentially sometimes there is a news that there is a thing that it can work with like a good compatibility, but still if you try to integrate and if you try to work it out, then like we have seen that there are issues. So we also do some bit of like CBCS, but it is like still we haven't done it like we are fully live with all the DRM, so we are also not sure.
Okay, good question. Then there's a question from Samrat. There's some very new technologies using technologies like WebGL to do AI upscaling and real-time video mixing and filters on the client. I can only assume that this will grow as clients get more powerful. As far as I'm aware, though, this is incompatible with DRM. Do you have any thoughts on whether these newer web technologies for client rendered videos, anime 4K, BBC video context, etc., would ever get supported by DRM? So WebGL technologies like WebGL, AI upscaling, real-time video mixing, filtering on the client side.
So DRM compatibility is like people try to improve it, but at the same time, security is a concern. So I feel it is like difficult for like DRM to be compatible in those cases. And if basically primarily in the browser, it is an HTML thing which is it is playing, and a browser has a CDM which is called a content decryption module, which facilitates secure like key exchange mechanism. So if uh, um, so I don't know like from like what are the technology details, but if something can be installed on a device. So suppose if you are asked to install something on your laptop, and then there might be like DRM can be possible, and also you might do other things like video mixing and other things which they were mentioning. But just on a browser level to do it in HTML, like both security and those kind of interactivities, that I feel currently is difficult.
Yeah. I mean, my own thoughts on this is that the CDM is designed not to allow the video frames to come out and to just securely get rendered. So if you install another module which gets access to the video, that will be a potential point of leakage. Anyway, Sam, do you have any questions, thoughts, or comments on that?
No, I mean, I think it was just, I had seen a few of these newer technologies come out. I specifically want to mention a company we talked to called Crunchyroll,
Yeah.
that had actually just mentioned this because they were using one of these systems, Anime 4K, which is an AI upscaler.
Okay.
But it was exactly as you mentioned, incompatible with DRM systems.
Yeah.
But they had actually put in a request with the Chrome team to see if it were possible to enable those kinds of use cases like AI upscaling in the future. So I understand that it's impossible, but I guess if it's up to browsers, I can see how there would be obviously that point of leakage. But I'm just curious if at some point people may figure out that there's a safe kind of sandbox way to do these kinds of AI upscaling and other things without those security concerns. I just thought it was an interesting kind of trend. I know there was a specific company that implemented DRM and tried to use one of these WebGL kind of AI upscaling filters and realized they were incompatible and decided to use the DRM implementation instead of the, and had to stop using the AI upscaling. I just thought it was an interesting kind of note within like an otherwise pretty good streaming service that's quite popular.
Yep. Cool.
Yeah. Thank you, Samrat. That was interesting. So I personally don't know much about how like the DRM working beyond video and audio, but the same DRMs are also used in like gaming systems, and so like yeah, so like it is so Widevine, for example, and Play Ready, they have these integrations even in gaming systems, and so yes, as you mentioned, that company also reached out to Google for having certain like integrations. So in like certain cases, yeah, it might be possible to get something from Google to be compatible in like future.
Okay. So I guess we'll take our last question. Any other questions beyond this? We can take it up in the Slack channel. So from Kaustubh, we have, in terms of implementation, if we want to work with multiple publishers and they have their own DRM preference, how do we solve that without blowing up our costs? Is there a player or a standard that could simplify this?
Also, in most like cases, so there are only three DRMs which are there. So Google, Microsoft, and Apple. So from these, so if you integrate these, then you serve all the browsers and all the apps. So in all the when I say all, I mean Android, iOS desktop, and also say Roku TV, Android TV, Chromecast, or Apple TV. So these are covered. So like in most like OTT platform cases, like people have to integrate these three DRMs, or at least Google and Apple, if not Microsoft, uh, to be able to serve everything. And this covers requirements from different providers. So typically, when a OTT platform which is gathering content from different content providers comes, so those content providers gives them a guideline and a form document to fill, that what will be your specifications and these are our guidelines. So like in most of those forms, what we have seen, so we have seen many like Hollywood based forms. So like there is already a mention of these three DRMs. So if you tick on those and you specify the details of it, then they are fine with it, because they also understand that this is what is mostly available out there in the market.
So just a follow up there. So Siddhant, does that mean we would have to, I mean, is there a way to simplify the implementation, or you have to pretty much go one by one?
No, the implementation is integrated. So, for example, if I think Alok, I don't know about Hoichi, but like say if a platform I'm taking content from, say Sony, Disney, Z in India, and also Warner, say Warner from outside. Okay, then they will have a different of their requirements. So while I'm building the video URL system, that how will the playback happen, which DRM, which security level should play where. So I can put those parameters on the finally video API side to have the URLs like built according to the requirements. So I don't have to maintain different systems for them, but yes, the logic at the video URL generation level can be different for different providers.
Okay, and have you seen in any of your implementation any abstraction of it? So for instance, let's say we want to do the example that you said. Is that, so sort of there is a plain vanilla implementation with minimal customization per publisher, or is that a rehash of the whole thing, like the video URL separation you mentioned?
So it is on the video level itself only. Okay, so as such, so it is on like whatever the platform has built. Suppose they have tagged this Disney content, these 100 videos. Now they have to maintain a separate like video URL generation system for these 100 videos, and for other providers they have to maintain a different system.
Okay. All right. Thank you.
Yeah. So we were recently working with one major Indian provider. So for Indian content, they didn't want like any security levels. They wanted everything to play everywhere. So like they wanted Google and Apple's DRM, and all Indian content can play everywhere. And highest quality can play everywhere. So it was the case for all the Indian providers. But then they had some like Hollywood content providers as well. So there they had to maintain this. So that is why for those videos they are implemented different logic.
Okay. Thank you.
Interesting. Okay, so I'll pause the session here so we can move on to Aditya. Thank you, Siddhant, for this wonderful presentation and for answering all the questions. If anybody has follow-up questions for Siddhant, you can ping him on Slack or on LinkedIn. His profile is there in all our ads for this session. Okay, thanks again, Siddhant. Over to Aditya.
Sure. Thanks. I will share my screen.
Thank you, Krishna. Thank you.
Thanks.
Let me know if you can see my screen.
Yep, we can see your screen.
Or you can still see it, right?
Yep, we can see it.
All right. So, hi guys. This is Aditya and Ankit, and we are going to talk about data processing in the context of video. So we'll start with introduction. We'll also discuss what we see on the business side, overall how the data management cycle works, what are the different data processing types, and then we'll talk specifically about video and OTT analytics. We'll also take an example of user or audience data stream architecture. And then last but not the least, kind of show you how a completely processed data stream looks like from a user consumption perspective. So that's kind of what we have planned for today. With that, just a quick introduction about myself. I'm Aditya. I'm the founder and CEO of Yuktamedia. We've been around for over 6+ years. Our primary focus is on data processing, and that to data processing in the display advertising space. Now, We did start with display, and then we have expanded into video, mobile, OOH, which is out of home, OTT, CTV, most recently. My background has been in ad tech for over a decade now. Used to work at Yahoo and PubMatic, and by trade, I'm a product manager. And in the last 6 years, we have kind of built an ERP for publishers and publisher networks, where they're able to collect all of their data and then leverage it across their organization. Let's say their CEOs and CROs, their ad operations team, their revenue ops team, so on and so forth. So we work with over 2,000 publishers across the globe and help them with automation, data analytics, and things around that. Along with me, I have Ankit, who is a senior software developer and who has been working on big data for over 5 years now. And we use a variety of tools for data collection and data processing, and he has listed a few here. So that's kind of our background. Most of our customers are based out of US, UK, UAE, and now expanding into Southeast Asia. With that, let's go into the digitization of the business. So if you look at how businesses have grown today, they are very, very data driven, and they want to have control over their own data set. They're always concerned about manual efforts around data collection, data processing, how to scale, and how to make the most out of that data. And in the process of doing that, they are also looking for reliable systems, always struggling with new data technologies. And these days it feels like almost every business needs to have an army of data engineers with them. But unfortunately, not all the businesses can afford that. And that's kind of the problem that we started solving specifically for the publishers and publisher network space across the globe. So that's how the businesses today interact with data, and those are the challenges. Now, if you look at data management life cycle, that is the most fundamental thing that any business needs to understand. Now, this is very generic, and we have built it so that every business can kind of understand what do they have to think about when it comes to managing their business data. So I would say there are 5 phases when it comes to data management cycle. One is you always have to start with understanding what are the business needs or user needs. We have seen scenarios where the businesses get so enamored by big data, large data, and they just want to capture all of that data, and they'll pay thousands of dollars to collect that data. But eventually, when you see what is the output of that data, or how applicable that data is, that's where everything starts to fall apart. And then they quickly realize that, yes, it all sounded very interesting, but we never really thought about what and how this data will be useful. So you always have to start with an end goal in mind, and that end goal has to be driven by your business needs, by your user needs, and your customer needs, so on and so forth. So keep your customers, users, business folks in consideration, or their needs, and take those into consideration, so that whatever you are doing from a data perspective kind of helps meet their goals. So that's the first part. And of course, those needs are always evolving. So it's not that you talk to them once and then kind of deliver what they're looking for and forget about it. You will see that it's a continuous ongoing process. It evolves over a period of time very, very rapidly. So you always have to have that constant communication to see how their business needs are changing. The other very important thing is when it comes to data, you'll always be working with a lot of different data partners and data formats. And today we work with over 100 different data providers from ad tech space, from martech space, from CRM, from finance, from social, you name it. And believe me, we have seen so many different variations of data and challenges that it keeps the evolution going. Every company is trying to evolve very, very rapidly from a data perspective, and how that data is provided to their partners and how it gets consumed. I think one of the best examples is Google's Google Ad Manager, which is used by almost all the publishers that we work with, and they update their data APIs, every 3 to 6 months or even faster at times, and they have a very solid roadmap. So there are companies like these who are always on top of data and how it gets consumed and shared. And then there are some companies who are not as aggressive, but again, this is something that as a business, when you're working with multiple data partners, you always have to think about how you're going to work with that data. Why is that data useful? What are the different data formats you are working with, and how would you, automate the data collection process, which is the third step, which is data gathering and processing. What we have seen is data gathering can vary very much from different providers and the usage of data. So there are real-time data streams where you're continuously polling for data and you're getting it and processing and utilizing it. And then there are batch processing scenarios where the data is updated every hour or every 4 hours or once a day, depending on the system that you're working with. So you have to make sure that when you're working with these different data partners, that you're able to kind of work with their data refresh frequency, that you're able to get that data and process it on your end in line with how they deliver the data to you. So that you have to keep that in mind. And then from a processing perspective, you have to make sure that once you have pulled the data in, that you have harmonized it, you have cleaned it, and you have validations on top of the process data, and even before that, so that you make sure that you have complete data set coming in. If there are issues, those flags are raised immediately at the time of collection, and at the time of processing. If there are issues, those flags are raised. Otherwise, what will happen is garbage in and garbage out. You'll spend a lot of cycles trying to process the data. You'll have a massive infrastructure, but you will see that if your input is not complete, accurate, and as expected, then your output is going to be completely off. And any other downstream systems that are going to utilize that data will just give very, very wrong indications. And if business decisions are made on that, it will result in real loss from a business perspective. So you have to make sure that you have the right check mechanisms in place at different points. The next is very critical, which is once after your data is pulled and processed, it is ready for analysis. And data analysis is a whole different ball game. You have to make sure that the data that is made ready for analysis is easy to consume. For example, if you have humongous amount of data and you have hundreds of users who are going to pull that data in or go sift through that data, then your queries have to be optimal. You have to pick the right kind of database, and you have to build the right kind of queries to pull that data in. And there are many flavors of this. We work with a number of different databases based on the type of usage of that data. So for power users, we have once a technology stack, and for your regular users, there's something else. So it can vary, but you have to make sure that at the end of the day, or whatever data you have collected and processed can be easily consumed, because if it's not easily consumed, again, your business users are not going to wait for hours and days to get answers to their queries, and eventually you will see that the data doesn't get used. So being able to respond rapidly to users' queries should be on the top of your mind. The other thing you should also remember is you should give the user the flexibility to schedule reports so that if they're asking the same question again and again, that answer is already there. That saves a lot of time. Third is if the user is going to do ad hoc queries, then the UI has to be very simple, very easy to use. And last but not the least, the system itself should give recommendations, and that we have seen by far the most important thing from a user perspective, where as the amount of data increases, you have to make sure that the system itself does a lot of data analysis on its side, and then gives recommendation to the users based on their roles. Then last but not the least is taking corrective actions. So when I say recommendations, that is where that leads to corrective actions. So one thing is telling a fact, which is this is what happened. The next is actually telling, if this is what happened, then these are the actions that you should take. And third is automatically taking those actions. So there are, at least in the publishing world, digital publishing world, there are ways to automatically take those actions by using right APIs, which look at data and make automatic changes to, let's say, your floor price or to your bid price, so on and so forth. So this is kind of overall the data management life cycle. You have to kind of think of all of these aspects as you're going through the thought of how you're going to manage the data. And I'm sure there are different variations of this, but this is a good starting point to at least get that thought process rolling. Moving on, like I said, there are different types of data processing. One is batch, the other is real time. And you always have to make a conscious decision on what type of data processing you have to use, because real-time data processing can be very costly. Of course, the costs are coming down, but it can still cost you money and resources. So when you're thinking about what type of process to use, you have to kind of think of what is the business impact of that data, or what is the cost to acquire, process, and maintain that data, right? What are the tools and skill sets required from the team to actually manage the entire end-to-end process? What do I have to do from a data retention perspective? And last but not the least, really, what is the ROI? So what if I were to process this data every 4 hours as opposed to every minute, or once a day as opposed to every 6 hours? You have to kind of make that trade-off. You have to think of those basic aspects and then think of what is the ROI, what is the impact from a business perspective of having this data every minute versus having it a little bit delayed. In case of publishing, we have seen that it's really interesting to have data every minute, but then the data fluctuates so much that there's almost like a point where you get best of both the worlds, where the fluctuations are in data are low and they're stable enough, and making decisions based on that data at that point gives you the best ROI. So these are some of the aspects that you have to think of from a data processing perspective. Moving on. So let's come to video and OTT analytics. This is the way we look at this is you have three different streams of or categories of data coming in. One is the ad monetization data. The other is user engagement and subscription data. And third is consumption and content consumption and distribution data. Like I said before, as a publisher, you'll have to work with a number of different partners to get all of these different data sets, right? The first one in ad monetization, you will work with a lot of ad servers, programmatic partners, and as you're showing ads and as your content gets monetized, all of this data you'll have to get back into your business systems so that you can make decisions based on that. Second is user engagement and subscription data. A lot of video and OTT analytics provider already have this data. There is definitely subscription data. Some of them also have user engagement, basic user engagement data. I've talked to a number of OTT providers who are trying to really understand the engagement aspect of their users. So they use different kinds of systems today to track that engagement. Basically, this constitutes an entire different data stream from a publisher perspective. And in this data, you will see the subscriber data, the audience engagement data, user counts, events, so on and so forth. And then the third data stream is the content consumption and distribution. So typically, the publishers that we work with will have a linear stream, will have a live stream, will have VOD, AVOD, and all the flavors. And for supporting all of these flavors, they will use systems like Whirl or Amagi or Viewed, or will also have their own mobile apps. So they will at least have anywhere between 7 to 8 different content distribution strategies, and from each of these systems you'll get data like hours viewed, total sessions, audience data, series and episode specific data, device level data, so on and so forth. So again, you have data coming from at least 10 to 15 different systems, and trying to make the sense of that data becomes very, very tricky. And again, all of this data is eventually used by many different teams within the organization. So you have to make sure that you collect it in a centralized fashion so that the data collection, cleansing, data processing, data mapping, data storage is done in a centralized manner. And once that is done, then it is pushed out to different users, either through dashboards, through insights, or or in another BI system where they can slice and dice the data, or get alerts and recommendations, so on and so forth. So once you collect all of this data, then the utilization of data becomes critical. So we'll take a look at how we manage the user or audience data stream and the systems that we use for the same. So I'll have Ankit kind of discuss this part because he's the one kind of who works on this.
Okay, thank you. So guys, let's look at these architectures from the left side. So we have the data sources. Different adapters are present, which works as an data collector. So we have a desktop adapter, Android adapter, and the iOS adapter. So all the data has been collected in the Kafka pipeline. Once the data has been collected, the consumers push the data to our S3 server in an Avro format. So once the files are being present in S3, so then we have the different we have a data processing flow aspect, which is handled by the Airflow, which monitors our S3 bucket. Once the files are present, the data processing is being triggered. So in data processing, we have different processing which has been done in like Apache Spark and Presto. So as taking the input as an Avro file, the file is been processed in Spark, and then the final output is in Parquet format. So different stages are present in data processing, like the cleaning, merging, calculation, and data loading. So on that data, some aggregation also needs to be done for some of the clients. So we use it as a Presto. So basically, the data processing part is done in Amazon EMR, because we have to scale up whenever required. So that configuration is being uh, very good in Amazon EMR. So once that is done, the final data has been used by the Yukta UI, and also alerts has been generated if any of the processing or any alerts need to be sent to the client. So this is the overall architecture we are using for user audience data stream.
And then once all the data is kind of processed, then it gets pushed into UI. So for example, here you can see, hours viewed, total sessions, monetization opportunities. You can see, and then you can derive conclusions like what is the most consumed video service, most viewed episodes, and then HOV by audience. So this is just a sample, but again, once you have that data completely processed, you can then slice and dice that data that is processed, and then that slicing and dicing can be done depending on the user roles and permissions, and what the user needs are. So again, you can create many different variations of this video data once it's processed.
Aditya, sorry to interrupt. If
Yeah.
you can go back one slide.
Yeah, sure.
We can spend a few more minutes explaining a few of the things like Avro, Parquet.
Yeah, sure.
Yeah.
What do these actually do?
So Avro is nothing but a different file format. So it is basically a write optimized file format. And it's also as we know that all the data which has been generated has been pushed in Kafka, right? There need to have some kind of validation. So for that we are using a schema registry which works as an data validation, and which supports Avro format. And as Avro is also write optimized, which is it can write around 1 million rows per second, and which is also compressed. It has a feature to compress the data. So that is why we have using Avro, which is a file format. Because if we use CSV and JSON format, I think that is a very difficult in sense we don't have any kind of validation as such, and it can be some kind of unstructured as well. So that is why we are using Avro file format. So another one is the output file format is Parquet, right? That is another one which is a Parquet file format. So it is basically a read optimized. So Presto and Hive, basically many technologies do have support for Parquet. As we know that we have to do some kind of aggregation or anything query. So that file format is good support for this technology. So we are using it Parquet. And Presto, we are using it because it is in-memory kind of database. So uh, that is why it is the retrieval time is pretty much fast when compared to other uh, databases. So that's why we are using as a Presto. And Airflow basically we are using this because it manages the data processing flow. As we know that we have different flows which might be dependent on one another, which can be run on parallel. So that's why we are using this Airflow. So here Airflow also does the work of uh, creating the clusters of EMR clusters, and once the data processing has been done, we terminate the clusters, due to which the infrastructure cost might be reduced. Because as we know that if we have to process the data in, let's say, for one day, we have to process it for 2 times. So why do we need to have the instances up for 24 hours, right? If whenever we have to process it, we create the clusters, process, and once the processing is done, we terminate the clusters. So that can be handled easily by the Airflow. So that is why we are using Airflow. And for Kafka, we all know that it's a data collection messaging queue which can be scaled easily, and it is good. So we are been using Kafka for data collection. So
Thanks a lot. Yeah.
Sure. So yeah, so I think this is the last slide that I have, which is again around the video data consumption. As you have seen, that once the data processing is done, then this is another format in which the data coming from various sources is tied together, and then the users get the insights about how much revenue they are generating, what is the consumption of various episodes and series or content, uh, uh, and what is the kind of engagement that's happening there, and then this can be used across different teams. So that's kind of what we had for today. I'm open for questions now.
Thanks. Probably I'll go first. So, Aditya, how do you take care of international data restrictions like GDPR, the California CCA, I forget, CCPA, I suppose it is. How do you design a system keeping those things in mind?
Great question. So a lot of GDPR and CCPA implementations are done at the time of ad serving itself, right? So for example, let's say if you're using Google Ad Manager or using SpotX or SpringServe or Freewheel for that matter, all of these different systems that actually serve ad have the responsibility to make sure that they are GDPR and CCPA compliant, number one. Number two, all the publishers now also have to implement what is called as a consent management system, right? So when the user goes to the website, you will see a lot of times now, you will see that you get a message saying, do you accept cookies, or yes or no, so on and so forth, right? So based on that consent, then a particular ad is shown, and data is then collected based on that consent. So all of that is taken care at the beginning and at the source itself. So by the time we get the data for processing, it's already in that compliant space.
Okay. That's it. Thanks. So we have a question from Karthikeyan.
Sure.
I think this is more relevant to your ad tech background.
Yeah.
Could you please share some insights on different ads, interactive ad, pause ad, and ad monetization? How do we see the future of ad tech in India?
Sure. So that's a great question. So what I believe will happen is, number one, is you will see from an India perspective, you will see a lot more variety in terms of the different types of ads that come into picture. Of course, gaming is growing as well. So you'll see different ad formats coming in. Number one, you will see a different level of compliant personalization that will happen to make ads more relevant to the end consumer. So I think those are the two things that I believe will happen from an India context as well.
Karthikeyan, any follow-up?
No, yeah, I'm good. Yeah, thank you, Aditya. Thank you so much. Yeah.
Any other questions? I suppose this is a general question, Aditya, for me. Going back to your architecture slide, right? What is scalable and what is not scalable in this?
So Ankit, you want to take that?
So I think it's yeah. If my question is not clear, let me know. But some things might be more easily scalable, something might not be. So if you could just give some ideas and thoughts around that.
So I think the data processing is pretty much scalable because it's been handled by the Amazon EMR. But on the data collection side, I think for now we need to monitor whether we are able to scale with the number of clusters which are already having.
So basically, I think what happens is everything can be scaled, right? So you can either scale horizontally or you can scale vertically. So it's only a matter of how and when you want to trigger scaling. Now, the scaling that is done at data collection will be different from scaling that is done at the time of data processing. But the basic fundamental thought process there is you want to be able to start new instances of the infrastructure so that you can scale. The question there is, as you bring up this infrastructure, your cost is also incrementally going to go up. So you have to take that into consideration as well. So how fast you want to get results is what is going to drive how you want to scale or how much you want to scale, right? If you want if the data size is very large and you want answers instantly, then you will have to scale much larger to a much larger scale, and that cost is going to go up. But you also have to see what is the ROI of scaling that fast and spending that much resources and money on the scaling, because if there's not that much ROI, then it doesn't really help. So you have to kind of balance between how much you want to scale and the ROI that you're going to get out of it.
Thanks. Thanks, Aditya. Thanks, Ankit. Yeah.
Sure.
So are there any other questions? I don't see anything in the chat. Siddhant, Kaustubh, Samit, anything else? Sanjeev?
No, nothing from my side.
So I have a question, which is more related to kind of what we do, is trying to match the data, not necessarily ad tech data, underlying content data from multiple providers.
Right.
So especially when we look at Indian OTT data, or even outside of India, there isn't really any standard for how OTT data is made available. Right? So while there are common fields and information, such as name of publisher, cast, crew, title, and things like that, we run into a lot of problems when we start dealing with Indian languages or with dirty data, right? Because inherently all this data is in English. And of course, we've over time figured out multiple ways to sort of clean it, use sound decks, things like that. But it continues to be an ongoing problem, right? Something where we see it's a continuous tussle to map and manage that. Because even before we can offer insights on usage and things like that, first our data needs to be clean.
Correct.
And so I wanted to know if you've had any experience like that, whether with Indian OTT data or outside, and what might have been some of your approaches to deal with that, beyond sort of brute force, right? We are kind of doing a lot of cleaning, brute force kind of checking and things like that. So, I mean, that's fine too, but I wanted to know if you've had any experience or exposure to that. And if so, what are some of the examples and approaches, a little bit that you can share, I would appreciate.
Sure, sure. So basically, what we do is, number one is, we keep, as we get data from, so for one of our US customers, what we do is, they distribute their data across many different platforms, and they want to track the engagement of the data across those platforms. So what we do is, we kind of create a unique identifier on our side, as opposed to depending on them to kind of identify the data. So we do a lot of unique identification of data, and at this we do it at the source, and then as we get that data, we are able to kind of join that together from data that is coming from different data sources. So that's one approach that we take, which seems to work. Number two is, we also at the source itself, we do a lot of nomenclature management, so that as it is pushed through different distribution platforms, that when it comes back, that we are able to easily kind of join that data and use it. So if you follow those, I mean, couple of processes right from the get-go, it becomes fairly less stressful to manage it later on from a data processing and consumption perspective.
Okay, yeah, thanks. No, I think we are doing that, some of it, but I think the problems are a little bit beyond that. But yeah, maybe we can discuss it.
Yeah, sure. Happy to discuss that. Yeah.
Cool. Any other questions? Again, both the speakers are available on our Slack channel. You can also find them on LinkedIn. So any follow-up discussions, if you have anything more to pick their brains, you can contact them easily. Okay, if there's nothing else, I guess we'll just wind up today's session. Again, a big thanks to everybody who joined us. A few people had to leave in the middle. I guess Saturday afternoon lunch must have interfered. But thanks for all the engaging questions. Thanks for the wonderful presentations, Aditya, Ankit, and Siddhant.
Sure.
So again, please let us know if anyone is interested in presenting. We can always discuss, come up with some very interesting topics relevant to the Indian context or just simply OTT. Fantastic. So Sanjeev, want to add something?
All right. Thank you, Aditya and Siddhant, and you guys for organizing.
Sure.
Really appreciate it. Enjoyed being here. Take care.
Thank you, Gustav. Okay.
I guess we are done now, right? We can log off.
Yeah. So I think Sanjeev, I thought that Sanjeev was trying to say something, but yeah.
Sorry, I'm back. Aditya, Siddhant,
Sure.
Sanjeev. Hey, sorry. I think I just lost my connection for a second. But anyway, thank you so much. We'll keep in touch. I'll publish the YouTube link as soon as possible and
Sure.
send it out to everyone.
All right. Thanks.
Yeah. Thank you, Krishna. Thank you, Sanjeev. Thank you, Aditya.
Cheers, guys. Cheers.
Thank you. Bye.
Bye.
Bye. Bye.